Yeah. So first of all, thank you all for joining us on this session. Um, uh, First of all, I want to thank to Galpa team to invite me to this, that we're gonna do. Okay, you don't see that. Um, that Thank you, Galpa, to invite me, and I'm really pleased to give you this training to all of you guys. During this session, we're gonna let me we're gonna talk about condensing units and evaporators, but also we're gonna see best practices and introduction on the Danfoss portfolio. But first of all, I want to start with the basics of refrigeration. This is one of the units that Danfoss sell, that is fractional condensing units. We just launched R290 condensing units in the market last year. Um, we used to have it in our refrigerant 134A and 4404. And now we'll just launch for R290. Those units, we built it in Monterrey, Mexico, and also the optimized slim condensing unit. We're going to talk about this specific unit later. And last but not least, we just launched this month the new condensing units of CO2 for 20 HP. This just brand new condensing unit for supermarket and big applications, I will say. So this is the range. I'm going to talk about this later. But first of all, I want to start with the part of the refrigeration because I want to of this. Um, this is what I what I can cover during the session. First, what is the basic refrigeration, the concepts, the basics, the pressures that we have regularly in a system, how we measure the pressure and how we convert that pressure into temperature that we want to need or do during the process, the different pressures between different refrigerants, the importance to have KPs and transducers and pressure switches in the system in order to protect the system and the heart of the condensing unit, that is the compressor. And also we're going to talk about transducers and controllers of a system. Well, first of all, let me introduce myself. My name is Ernesto Ramirez. I've been working in Danfoss since 2006. I mean, for more than 20 years in the company. And I have several roles in the organization, like application, sales, customer service supervisor, and then I moved to the wholesaler in Latin America. And now my current role is walk-in cooler business developer manager for North America. And like I said, I'm really pleased to be here. So I'm going to start with the basics. This is the four critical or the four elements that we need to have in a refrigeration system. We need to have a condenser, we need to have an evaporator, a compressor, an expansion device. In a refrigeration circle, we need to. It is like the water. We need the circle of water. You need to have the different stations of the fluid. You need to have vapor. You need to have liquid and a mix of liquid gas or gas liquid. We're gonna see it during this process. What is the most critical thing in the system? You need to remove heat that we have in a walk-in cooler or in a freezer or in a room like this. We need to remove all the heat that we have here and put it outside in an ambient temperature, or we could use another fluid like water, glycol, you name it. The idea is to remove that heat and transfer to another area. So talking about that, we need at least 4 critical elements like that I'm going to mention here. As you can see, this is a regular like diagram of any fluid had a similar diagram of enthalpy that we have in a refrigeration system that you need. If you go, let me to the pointer here in order to show it. So we start with the compressor that here, remember that the compressor is our heart of our system. So the compressor, like the name said, need to compress the gas that we have in the system. And we need to ensure that we only have gas on the system in order to don't have any problem with the compressor. So in order to ensure that the refrigerant it is in gas, we need to add this extra heat in order to only have gas on the chamber of the compressor. Do you know the name of that? How we call that that extra heat that we add to the system? That's how we call it, superheat. Have you ever heard superheat? Subcooling is another thing that we're gonna see later, but this is the superheat. Remember that if you see the diagram here we have a mix of liquid and gas before you enter to the evaporator, okay? When you have the evaporator, if you put here the evaporator, what you are doing is absorb all the heat that we have, because we are like warm, so we are transferring heat to the ambient. So that evaporator absorbs that heat and put it on the refrigerant. And if you put it on that refrigerant, what you are doing is put that heat and move from mix of liquid and gas. And if you go to the right, you're going to have, for instance, here you're going to have 10% liquid, 90% gas. And if you go further to the right side, you're going to have, here you're going to have 100% of gas, 0% of liquid. But keep it in mind that you must ensure that you only have gas on the system, okay? So what you need to do is add extra heat in order to ensure to don't have any problem with the compressor. So that's what we call superheat, okay? It's that extra heat in order to don't have liquid on the inside the compressor, okay? It is, we call it in Spanish, mal necesario, but you need it because if you have a big superheat, it's also dangerous because you could damage the compressor, because remember that the refrigerant also freeze the compressor in order to cool the compressor. So you don't need to have a big superheat, but you need to have a good one, okay? Of course, if you have a small superheat, you're gonna have a most efficient system. but it is also a risk because you could be on the edge between gas and liquid. So you need to you need to consider that. Okay. So when you add pressure, you compress the gas and set it in a high pressure to the system in the discharge pipe that is here, and you send it to the condenser. So when you send it here, it is in gas, overheat, and when you put it on the condenser, you're gonna do the transfer or the change of the phase of the refrigerant. You're gonna move from gas. When enter to this area, you're gonna have a mix again, okay, of liquid and gas. Okay. If you release the heat that you get from this room, you're gonna release it on the ambient, and when you transfer that heat, you're gonna transform that refrigerant in liquid. So if you move further to the left, here in the pond A, you're gonna have 100% liquid, 0% gas. Okay, but again, you're gonna need a subcooling to confirm that you only have liquid on the system. Do you know how in the system you could confirm if you only have liquid? On the side glass. That's correct. If you see in the side glass bubbles, you have a mix there in the liquid line. So you must ensure that you only have liquid on the system. Why? Because before the TXV, you must ensure that you only have liquid. Because if you have a mixture, you're gonna start doing like flash gases to the evaporator. And that's dangerous because when you put like flash gases to the evaporator, you're gonna drop a lot of quantity of refrigerant, and the evaporator don't have the capacity to absorb heat and evaporate that refrigerant. So that liquid going directly to the compressor. And remember that the compressor cannot compress liquids. If the liquid is impossible to compress it. So you need to ensure that you only have gas before the compressor. And before the TXV, you must ensure to have only liquid. Okay, that's critical. So that's the reason that you need to have the superheat in order to only have gas, and subcooling in order to only have liquid before the TXV. Okay? And what is the function of the TXV? To do the drop of pressure on the system, to help to do the change of phase of the refrigerant. Here is before the TXV. When passed through the orifice of the TXV, could be a piston, or could be a electronic expansion valve. You're gonna do the drop of the pressure, and look what's happened. When you drop the pressure, you're gonna have here a mix. You're gonna have here, you have like 10% of liquid. 90% of liquid, 10% of gas. But you add the heat of all the people that it is inside of this room, for instance, in this situation, this heat, and you're gonna transfer and move that refrigerant from a phase of 10% of gas and 90% of liquid to transfer to a 100% gas, 0% liquid. Okay?
And ahí donde dice admit arriba.
Yeah. Let me meet the people.
Thank you.
Okay. It is clear here. So this is the cycle of refrigeration. It is necessary to understand all the components that we're going to see during the session. So it is 4 components. It is the condenser, the compressor, the evaporator, and the expansion device.
There's someone else to me.
Okay, yeah, Charles Henry.
Thank you.
Okay. So as you can see, this is the 4 critical components. Of course, we have pressure switches, ball valves, KPs, pressure switches, etc. Another components that helps or give more security or ensure that the system works in the envelope of the compressor, because the compressor has an envelope where it works perfect. If you move outside of that envelope, it's dangerous for the compressor. And remember that the thing that we need to protect, it is the compressor, because it's the heart of our system. So that's critical to understand. I'm going to move to the next slide. Okay, I'm going to talk about the different components of, at least for the 4 critical components that we saw on that diagram. The first one is the evaporator. As we mentioned, the function of this circuit for the evaporator is to absorb the heat of, for instance, in a walk-in cooler, if we have meat, we put that meat or beef in, I don't know, we put it on 70 degrees Fahrenheit or 90 degrees, and we want to remove that heat and of the system. So that is the main function of the evaporator, to absorb all the heat that we have on the cold room, or for instance, if it is air conditioning, all the heat that we have here in order to put it outside on the ambient. The function of the condenser is to release that heat, okay? One critical thing that you need to understand is that one of the rules of the heat is that you need to have a higher temperature on the condenser if you want to transfer that heat to the ambient. If we have a below temperature than the ambient temperature, you don't gonna get you don't gonna release that heat to the ambient. So you must ensure that the temperature of the condenser is higher than the ambient temperature. Okay, so that's the reason that you need to have a delta temperature of the system. Oh yeah, you could get it. No, you could have it, and if you see it, you could click it. So that is the main function of the condensator. Of course, in this unit is a condensing unit. That means that we have more components. Here in the condensing unit, we have at least 2 critical components of the refrigeration system. It is the compressor and the condenser. And of course, we have a receiver and also some other components that we're going to see later that helps to maintain a safety protections on the system in order to don't have any problem during the installation. But yeah, the condenser, it is critical to release that heat that we obtain from the chamber, the cold room, the room, whatever we want to extract the heat. Do you have any question? No? Okay, compressor. What this like I mentioned before, this is the heart of our system, and the main function is to compress the gas that we have after the evaporator and increase the pressure in order to have a big pressure and remember the one of the rules of the pressure of Newton. It is that if you increase the pressure, what you get? You increase also the temperature.
The temperature.
And if you increase the temperature, you increase the pressure. So this is one of the main functions that you have in the system. It is that to increase the pressure and increase the temperature of your system in order to be up of the ambient temperature that we have on the ambient, right? That's one of the things that we already discussed. Superheat, it is the extra heat that we add to the system in order to ensure that we only have gas before the compressor. Okay? It is necessary, but if you have a big superheat, it's also dangerous. But if you have a small, it's also a risk to have liquid on the system before the compressor. So remember, compressor cannot compress liquid. So we must ensure to have gas before that, okay? And the subcooling is the same. It is remove the heat that we have on the system, the extra heat that we have, in order to ensure that we convert completely the mix of liquid gas to only have liquid on the system. We need to ensure to have only liquid or the expansion device that you have. Okay? Okay, so this is a thermostatic expansion valve. The thermostatic expansion valve, I'm gonna switch here because I want to explain better. I don't know if you are seeing the screen, but what we have here, the TXV and the EEV works like with superheat. What is superheat? It is the extra heat that we add in order to ensure that we only have, at the end of the evaporator, we only have 100% gas, okay? So we're gonna measure the superheat. Okay, how we measure that? We need to measure the pressure at the end of the evaporator and also the temperature. And the difference, it is the extra superheat that we have. But the pressure, you need to convert it in temperature. Okay?
Saturación.
The pressure, the saturated pressure, that's correct. We have tables. Danfoss Galpa application, that is Ref Slider. I don't know if have you ever heard about that before. Let me show you. It is free. It is in Apple Store and also in Android. It is this one.
Ref,
Yeah. The Ref tool, yeah. So you could put here, we're gonna see it during the presentation. You could put it here, the pressure. You could put it in bars, on PSIs, whatever you are familiar with. And you will get here also the temperature in Fahrenheit, Celsius, Kelvin, whatever you use regularly. But it is easy. So that's the reason that it's really, really important to install correctly the TXV. Remember that the bulb, you need to put it on the top. Why on the top? If you have the pipe,
the 4 or 8, C4.
yeah. If you have the pipe, depending on the size of the pipe. Yeah, you're right. If it is a small one, you need to put it on the top. You don't have a lot of space to put it on. But if it is really big, you could put it like you say, you could put it at 3 p.m. If you have it like a clock, you can put it at 3, at 12, or at 9, right? Because keep it in mind that the system needs oil. So in a pipe, at the bottom, you have the oil, correct? So if you put it on the bottom, you are measuring the temperature of the oil. And of course, it's a different temperature because the temperature of the oil is totally different as the refrigerant. So if you put it on the top, you're going to measure the temperature of the oil. And another important thing is that you need to isolate the bulb, because if you put it in a ambient temperature, you're going to measure the temperature of the ambient, and it's not gonna work properly because you're gonna have a big differential of temperature, because probably there is 10 degrees higher than the temperature that you are measuring here, or you don't know. So that's the reason that you need to isolate it correctly and put it correctly on the pipe. Okay? And if you know that you have at least 7 psi's or 2 bars of differential in the piping, a drop or an increase of pressure inside of the evaporator, you need to put an equalizer on the TXP. What is the equalizer? It is a pipe that's gonna sense the pressure at the end of the evaporator. Okay?
A partir de qué caballaje, 1,5 para arriba, o
No. Is if you have a distributor on the evaporator, you need to include an equalizer.
okay.
Because in the distributor that is after the TXP, you're gonna put like different pipes during the evaporator, and you have different diameters of
Un pesador de presión.
and if you have different sizes of pipe, you're gonna have differential of pressure after the TXP to measure that differential.
Sí, la caída de presión para ecualizar la caída de presión.
That's correct. So that's the reason. If you have a distributor or inside, if you can only ensure that the pipe inside of the evaporator it is the same as you have at the end of the TXB, you need to add an equalizer. An equalizer on the TXB. Because you need to measure that differential of pressure that you have after the TXB. So you need to measure and put it that equalizer. Also, it is really important that pipe is gonna be on the top of the disc. Of the pipe. Because if you put it on the bottom, what you're gonna get? You're gonna get the oil. Actually, what you could get is that all the oil is going to the equalizer and block the sensing of the pressure. So it is really important to put it also correctly. It is recommended to put it on the top, or at least like 3, 9, or 12. Between that frame, you could do it, and it is really helpful. Also, I don't recommend to put it in a vertical way, because it is impossible to know if you're gonna have what you are measuring. If you are measuring the pressure of the oil or pressure of the refrigerant. I know that in some cases you don't have enough room to put it wherever you want it, but if you have room to put it in a horizontal way, do it. Okay, that's the recommendation that we do, not only for the Danfoss TSB, for any TXP that we have on the market. Okay? Questions for that?
Okay.
No? You have the most? Could you click on chat? Oh. On one? Can you share it again?
I don't know what I did.
Let me do it again. Oh, you closed it. I
Wow.
don't know what's going on.
I think you need to. Oye, ¿está cerrada la presentación?
Yes, sí. Aquí está.
Que compartir.
There you go. But I need to share again, right?
Yeah.
Do you see my screen now? Do you see it? Yeah, okay. Okay. Well, I already talked about it, but like repeating what I said before, the main function of the TXV is to switch. Remember before that, we only have liquid, right? So what we're gonna do is we're gonna drop the pressure because it's gonna pass through a small orifice. And keep it in mind that how the TXV works, it is, for instance, now we are 10 persons in this room, right? If in this moment I remove 5 people that need to go to do something outside of this room, what we want to have? We're going to have less charge or heat in this room. That's correct? Because we don't have enough, we remove heat from the room. So we don't need a lot of refrigerant to absorb all the heat that we have in the room. So the TXV must reduce the quantity of refrigerant that we're gonna add to the evaporator, right? So that's how the TXV works. Let me go to this slide. So if we remove people from this room and we supply the same amount of refrigerant, what we want to have is a lot of refrigerant, and it is possible that the evaporator, which we have 100% of gas here. But if we add more people, this is gonna move, and we're gonna have here the 100% of the of gas.
Okay.
That's correct. So that's what the TXV do, is reduce the amount of refrigerant that we supply to the evaporator, and try to equalize that we have, even if we take out people from this room or add more people, to be like here, try to equalize the up and down of close the valve in order to only supply the enough refrigerant that we need on that system. That's the main function of the TXV, to open and close depend of that. And how it works is, if we have 4 kelvins, the TXV start to open the TXV. And from that point to 10 Kelvin, it's gonna be working open gradually and close it if it is below 4 Kelvin.
Lo que se encarga de control ese sobrecalentamiento. La TXV es la encargada de eso, de controlar ese sobrecalentamiento.
Yeah.
Esa es la función de la TXV.
Yeah. And for instance, at least for the Danfoss TXV, it start at 4 Kelvin, the opening of the TXV. That means that if you don't have 4 Kelvin, the valve will be closed, right?
Sí.
So you need to have at least 4 Kelvin, but you can adjust it. That's the reason that you have like a device there that if you turn,
Para abrir o cerrar.
depends of if you open to the right or to the left.
Sí, no, pues sí, así. Abrir la contraria y cerrarlo.
That's correct. So it is, and what you should do is to do like a half of a turn and leave it like that for 2-3 minutes and start to see the behavior of the.
A volverlo otra vez a abrir.
If you need more, you could adjust it a little bit further.
Depende, está muy alto, abrirla, si está muy cerrada, si tiene muy poco superheat, entonces hay que cerrar un poquito,
Así es.
aumentar la...
Yeah, that's correct. You need to, depends of what you need, you could adjust it or you could turn it back.
Depende, siempre depende.
Uh-huh. So it is critical to adjust that, but first you must ensure that you chart properly the system. We're gonna see it later, how we ensure that. Because normally when you charge the refrigerant, you also need to check the subcooling of the what is the difference that you have there in order to ensure that you have the proper refrigerant on the system. But yeah, you need to maintain a stable superheat on the system. If you see that you have, for instance, currently you have 4 degrees and then goes up to 12 and then goes down to 8, and then you have the different in a short time, it's not good, because what it's doing there is that you have they call it hunting, and what you are doing is that the TXV is opening 100% and then close it drastically to 0,
No.
and then open
Flash gas.
is flash gas. Normally, that means that the TXV is too big for the system. Okay? When you have that kind of situation, is that the valve is too big, that when tries to open 100%, but then knows that, oh, I'm supplying a lot of refrigerant, so try to reduce it drastically and close it, and then open it and close it. So it is too big. So you need to a smaller TXV. It is important when you're selecting the TXV that do it accordingly to the capacity of the evaporator, not of the condenser or the compressor. Regularly, we say, okay, it's a 5 HP condensing unit, so I need, I don't know, 65,000 BTUs. Okay, so I select the TXV 65,000 BTUs. No, because probably that condensing unit, it is supplying to 2 evaporators. In one evaporator is 35 or 32,000, and the other one is 32,000. So you need to put the orifice, the TXV of 32,000 to that evaporator. Because if you put 65,000 to one evaporator of 32,000, it's gonna be so big that TXV.
Una pregunta. Entonces, ¿es incorrecto seleccionar la TV por el caballaje del compresor?
Sí, es incorrecto.
Es incorrecto. Yo lo estaba haciendo así porque sí, en algunos casos se ven los datos del evaporador, pero cuando no.
No es totalmente equivocado, because I'm going to switch in English.
Try to repeat the question in English.
Okay. He is asking if that regularly I selected the compressor, the TXV with the size of the compressor. And that's not totally a lie, a mistake, but could be dangerous because, for instance, like I mentioned before, if you have an evaporator that you have 2 evaporators or 3 evaporators or only one compressor, you're gonna need to split the capacity in different. Or sometimes you don't have the evaporator that fits to that condensing unit. For instance, you have a condensing unit of at that conditions give you 65,000 BTUs, but you don't have the match of the evaporator, so you select an evaporator of 70,000 or 50,000 BTUs, because the walk-in cooler need only 50,000.
Okay.
But you put a big condensing unit because you don't have the condensing unit of 50,000, and you put a 60,000 BTUs. So you put an evaporator that is small. But if you put the TXV of 60,000, remember that the evaporator can only give you 50,000 BTUs.
Yeah.
So if you put a 60,000 BTUs in the evaporator, it's gonna be so big for that evaporator.
Sí, cada evaporador o la capacidad que lleva.
Okay. Yeah.
Okay.
So you must put the capacity of the evaporator in that conditions. Okay? Because if not, you're gonna have a big TXV. Okay? So in summary, remember the key facts that we have here is 4 critical components. Sorry, we have the compressor, the evaporator, the TXV, and the condenser. Before the compressor, we must have a superheat. We ensure it with the TXV, with MOP, we ensure that we only have a minimum pressure, and in that way, we ensure that we have only a big superheat. This superheat, that we only have gas. Subcooling is the heat that we remove in order to ensure that we only have liquid on the system. The TXV pressure, the compressor, increase the pressure, compress the gas, and convert it in high temperature gas, super saturated. And in the condenser, we remove that heat that we got from this room or from the walk-in cooler. And like that. Oh, sorry. And with the evaporator, we absorb that heat from the room that we're gonna remove. In this slide, I put the extra accessories that help us to maintain a healthy system in our refrigerant circle. Circle of refrigeration. What we have here? Okay. We have the same component that we saw on the regular system. We have here the condenser. There we have the evaporator, the TXV before the evaporator. Before the evaporator. After the evaporator, we have the compressor, but before that, we have this suction pressure regulator. Why we have it before? When the system is turned off, regularly the temperature of the system was supposed to be on hermetic, so you don't have any pressure or any disruption of the ambient. So it's gonna try to equalize the pressures in the suction line and in the liquid line. That's correct. So you could have in the evaporator liquid. Okay, so when you turn on the compressor, you must ensure that you don't have that liquid entering again to the compressor. Okay, so with that pressure regulator, what you are doing is ensuring that before you start running again the compressor, you only have gas before the compressor. Okay.
So hace regular la presión constante del compresor nada.
Yeah, you're gonna ensure to have a big, big pressure. And remember what we mentioned before. If you increase the pressure, what you get? Big temperature.
Big temperature.
And with that, we ensure that we convert the refrigerant that we have in the evaporator in gas. Okay, so you're gonna increase the pressure here until we convert it to gas, and then when it gets to that pressure, release the refrigerant to the compressor. Okay?
Evitar golpe líquido.
Yes.
Yeah, but this is maintain for pressure in the evaporator.
Again?
For maintain pressure in the evaporator, sample for 30 psi, and before for the pressure regulator maybe 20. Because it's another tool for the ice and the compressor.
Yeah.
This is every time maintain for expansion valve and evaporator, sometime for the temperature. This is for pressure regulator, which is very important for the compressor.
Yeah, that's correct. So it is really good for the compressor and mainly for the scroll compressor.
It's adjusted.
Yeah. Yeah, you could adjust it on the top. Yeah, you could turn it with
Because it's mounting every time the pressure that is back in the evaporator.
yeah.
If you know temperature is down, because it's down is the pressure and the frozen for the compressor.
Yeah, and you're gonna get liquid before to the compressor and you're gonna break it.
Yeah, this is function for the social pressure.
Yeah.
Okay.
Also, one protection that we put on the system is we put a crankcase on the bottom of the compressor. Also for protection, because here you could condense the refrigerant that we have on the bottom. And when you turn it on, you're gonna get it to to the piston. In this case, it's pistons, could be a scroll compressor. So if you put a crankcase heater, you're gonna maintain at least a temperature that ensures you only have gas on the bottom of the compressor. That's also a protection that you have on the system. So that's another protection. So we have 1, 2. The next one is the pressure switches. Like I mentioned before, we need to have an envelope. All the compressors have an envelope where it works properly. If you move it outside of that, you could damage your compressor. Remember, the compressor is the heart of the system. So we must ensure that we are protecting that is not working out of that. So it is really important to have correctly set the pressure in the suction line and also in the discharge line. So if you have an overheat before the compressor, you must turn it off in order to protect it. So it is a protection of the system, this pressure switch. And also, if you have a big superheat, big pressure on the liquid in the discharge line, you also have something wrong. Probably you are adding a small quantity of refrigerant, or the TXV is blocked, or something is wrong on the system. The fan motors are not working. I don't know. You need to investigate why you have a high pressure here. So what this thing do is turn it off also in order to protect the compressor. This is a really good protection, but you must ensure to put it on the correct pressure. So that's the reason that you need to use the ref slider. For instance, if it is 404 refrigerant, you convert it and check it. Okay, what is the regular pressure that I must have here? I don't know, 230 psi.
250,
to 60.
Yeah.
250.
In the suction line, I must have, I don't know, 90 psi.
5 or 10 is better for the compressor because it's hermetic. It's a little down, example for 5 or 0 psi is the oil separator, it's immigration for the evaporator.
Yeah.
So every time you need the pressure and the suction, maybe 10 or 50 psi. That's it.
And it's not the same if you have 448, 449, as if you have 404.
Yeah.
So depends on the refrigerant. It is the pressure that you must set on this pressure switch. So it is really important. Depends because, for instance, the Danfoss condensing unit that we have on the market is going to be multi-refrigerant. So you could put A12 refrigerants. 454C or A, or you could have 448, 449, or we could have 404, R22, because in some cases we're still using those. So depends on those refrigerants, you need to set accordingly the pressure on the suction line or on the high side of the system. Okay. Also, we have these 3 components. We already discussed about some of them. What is the function of the filter dryer?
¿Verdad?
¿Verdad?
The wet.
Dry every time.
Okay. One, humidity is, of course, the most important because we cannot have moisture or humidity in the system. So that's the reason that we must ensure to have two sinks when we're doing the installation of the refrigeration system. One is to do a proper vacuum on the system in order to remove all the moisture that we have inside of the pipings. The second one, it is when we brace the connections, do it and apply nitrogen to the pipes. Why? Because if you don't apply nitrogen when you are bracing, what you're doing is you are burning, the connection, and you are putting carbon inside of the system, and that carbon is gonna be circulating in the system, and together with the oil of the compressor, plus the refrigerant that you add, plus the moisture that you have on the ambient, and you don't remove it during your installation, it's gonna make like a paste or something really bad on the system that could block the tiniest orifice that you have on your system, that is the TXV. So that's really important. And so if we do a bad installation, the filter dryer is gonna absorb that moisture or that muck or all the moisture, they're gonna retain it. But also, if you have some particles of copper, when you cook the pipe, all those small parts, at least the filter dryer of Danfoss has a tolerance of 18 microns. So every small particles of 18 microns could absorb it in the filter dryer. So that's the reason that every time that you do a service to a system, you must remove and replace the filter dryer. Always. You need to do it. And the other thing that we must have is the cycles. In order, when you are charging the refrigerant, you must ensure that in the cycles.
Si tiene humedad, porque tiene
Yeah.
la cantidad de líquido que entra en la válvula también.
So, yeah, normally the cycles have two functions. One is if you change the color, it's gonna detect if you have moisture. If you have moisture, you must do again vacuum and then charge it again. Or you have a leak on the system. You need to find the leak. If you don't have moisture, I mean, you also need to see that you don't have bubbles on it. If you have bubbles, it could be two things. One is that you need to add more refrigerant, or the valve is so big, or you could also need to check, because sometimes the filter is already blocked, and that's really easy to detect it, because you're gonna see after the filter, you're gonna see frozen this pipe. If you see it like that, that's because the filter dryer is blocked and you need to replace it. Okay, so you must ensure that you don't have bubbles on the side glass. But of course, you need to turn the compressor, see the system for a long period to see, because to stabilize the system correctly. If after 4 or 5 minutes you don't see bubbles, it is great. If you see bubbles, you need to adjust something. You need to check pressures and everything in order that you have everything quite good on the system. Okay? What else we have here extra? GBC valves or ball valves. What is the ball valves? What is the reason for those? Mainly, What
have it.
happened?
You need to go back.
Yeah.
I can.
There it is. It is for service. If you see, we have one here and another one here. So if you close here and here, you could replace the filter and you maintain the circuit hermetic. So that's a benefit. That's the reason that we put, this is a mechanical, but also you could put a solenoid valve and you will have the same. Of course, it's the price of these ones is competitive rather if you compare it versus electronic electronic device. And that's the reason that you put it there. Also, we have another component that is the solenoid valve. This one is the most used configuration that you're gonna see on a walk-in cooler. I will say why? Because help you if you want to turn off the system, you don't turn off directly the compressor. What you're gonna do is if you want to close or turn off the compressor, you close the EVR or the solenoid valve, and what you're gonna have? What do you think you're gonna have after that solenoid valve?
Y para chequear si la válvula está abierta.
Yeah. What you're gonna get is a drop of pressure after that. So you're going, this pressure that you're gonna have before the compressor is gonna drop drastically because you don't have refrigerant on this pipe. And if you have a low pressure here, you're gonna go here and you're gonna close it. Okay? And what you're gonna have is you're gonna have all the refrigerant before the EVR. So when you turn on the compressor, again, this refrigerant gonna pass through the evaporator. It's gonna evaporate the liquid that you have before that. And you're gonna ensure that you only have gas before the compressor. So the importance of the solenoid valve, it is critical to put it before the TXV, okay? And also for services, if you close the solenoid valve, you're gonna ensure that you don't have refrigerant after the solenoid valve, okay? So that's a critical function that you have with the solenoid valve. This is the most common. Also, the other one is the electronic thermostat. Could be a mechanical or could be electronical. Normally now it's easier the electronic because it's cheaper and also it's really fast. You only need a PT1000 to sensing. I mean, you could do it like with 4 sensors or with only one. But for instance, if you have a defrost, you could have a sensor that detects normally on the bottom of the evaporator. Also, one sensor that you put it before the evaporator when you are absorbing the heat from the room of the walk-in cooler. And another one that is after you throwing all that fresh air to the system. And what you're gonna do is a put in, put out. You need to have in your room, I don't know, -20 Celsius. So you need to add a differential, depends on the evaporator. Normally, the evaporators that we have is a delta of 10 kelvins. So you need to add that differential. So if you want to have a -20 in your room, you need to add 10 degrees more in order to do the proper transfer that you have only 20 degrees in your room. Questions here? Or could you Could you move to the next one? Yeah. Oh, okay. Now I'm gonna move to how to do the pressure. I mean, to sense the pressure on the system. And in order to have the proper pressure that, like you mentioned before, we need to ensure that we have the correct pressure depends on the refrigerant that we have on the system. So, for instance, if we need to have a minus 20 Celsius here in this room, slope, we want to, so we need to add that differential of the evaporator. So we need minus 30 here. I mean, at the end of the evaporator. So what do you think should be the pressure after the evaporator? For instance, if we have 4 and I need minus 20, minus 30.
La temperatura de saturación,
Uh-huh.
pero ¿qué temperatura tenemos el cooler primero? Sí, ¿a qué temperatura yo quiero el cooler? Esa es la pregunta.
Uh-huh.
Si a 10, yo le meto 10 Fahrenheit, me va a la temperatura de saturación que yo necesito del refrigerante.
Okay. So if I need minus 3 Fahrenheit, Fahrenheit?
Sí, Fahrenheit.
In minus 13.
35 o... Sí, la temperatura que yo del cooler, ¿cuál es? 35.
No.
Bueno, si es 35, 404, aquí voy a tener 34 Fahrenheit de saturación.
Okay. What is the pressure that you must have?
76.
76. So we need to have 76 psi here in order to ensure that we have the correct temperature on the room. I mean, in the walking pool. Okay. What about on the discharge? We also protect that we don't have an overheat. I mean, extra superheat on the system. So we need to check the data sheet of the compressor. Depends of every compressor have a different parameters of the envelope of the compressor. So if you have a really big temperature or pressure, it is dangerous here because you're gonna damage the elements internally. So depends of the refrigerant and also of the envelope of the compressor. You need to adjust the KP of this of your or the pressure switch that you have. For instance, for a 404, regularly, if you have 45, if we have 35 degrees on the ambient temperature, that is like 95 degrees.
95, sí. More 50, is it 15 or 30?
Yeah, that's correct. So you need to have at least 110 Fahrenheit.
Sí, como 15 más o menos, 115.
Could you check what is the pressure of that?
Más o menos 273.
So you must ensure that you have 273 psi here on the suction, in the suction, in the discharge, in the discharge line. So that's critical. That you need to adjust, and you need to set it in order to protect the compressor in the suction side and in the discharge side. Okay. And with that, you're going to ensure that you have a higher temperature at the end of the system, I mean, in the condenser, in order to transfer that heat to the ambient temperature. And also to have the correct temperature on the evaporator in order to get the temperature that you need on the walking pool. It is clear here?
Oh, good.
Oh, sorry. So here's an example. I did it in Celsius. Yes, I'm used to, but I could compare it. I already know the temperatures. So how you gonna get it? The low pressure means low temperature, right? So low temperature means evaporating temperature because it is in the suction line. So if I have evaporating temperature, it is a set point that I want to have. But also I need to consider the delta T of the evaporator. Depends of every evaporator has different delta T's. So you need to check, at least for the ones that we have of Danfoss is a 6 Celsius differential. So if you have, for instance, you want to get to minus 20 Celsius, you need to add this 6. So you need to convert minus 26 in pressure, saturated pressure, and you're gonna get what is the pressure that you need of the suctions. That's what we already discussed, right?
Yeah.
For the high pressure is totally similar. You need to consider the differential of the condenser. You need to consider the delta T of the condenser. So here, if the ambient temperature is 32 Celsius, you need to have a differential of 12 Celsius. So you need to add it, and you're gonna get 44 degrees. You convert it in pressure, and that's the pressure that you need to have on the highs. Okay? Question here? Question here? Here? So this is a summary of what we just talked. This is a cold room. Here, I must have in this case, we need to have minus 20 here. So what we do is we set the suction line minus 26 in order to have here minus 20. Okay? And in the discharge, we must have 44 degrees in order to ensure that we transfer that heat to the ambient. So we need 12 degrees Celsius on this case. So what we do is we convert 44 Celsius into pressure, and that's the pressure that I must have here. Okay? Okay, this is the tool that I just showed you. Here you could put the refrigerant. You could change it to any refrigerant that you may have or are using, not only for refrigeration, also for air conditioning, CO2, ammonia, or you name it. We have all the refrigerants, sorry. And you could choose it, and you could put here the pressure. You could put it on bars, PSIs, so whatever you are familiar with, and you're gonna get here the pressure that you need to have on your system. So this is, well, it is in Spanish, but
in the presentation, right?
In the presentation, but you could put it on English, French, Portuguese, English, you name it. All the Danish. We're a Danish company, so we should have it on that one. But what's
the name of that?
Again?
What's the name of that?
It's Ref Slider. Let me show you again. Ref Slider. It is for free.
No, it's RF.
Oh, that one.
RF tool.
Yeah.
Oh,
The logo is like this.
Ref tool. Yes, no.
oh, okay.
It is Red Tools.
Yeah.
Yeah, I got it. Okay.
It is for free in Android and Apple iOS. But yeah, it's pretty easy. I mean, you could change the pressure to PSI, bars, the pressure in Celsius, Fahrenheit, distance, you could put it in meters or feet. So, and also you could put it in English and Spanish, any language that you want. And what we have here is, oh, sorry. So I put for instance, you could put here 44. Well, and you must change to 404. Then you're gonna get the pressure that you need to have on the discharge or in the liquid line. No, discharge side, in order to get to transfer the heat that we're moving for the evaporator. And in the suction line, we put here what we say, 32 Celsius.
No, Fahrenheit.
Oh, was 32 Fahrenheit?
Fahrenheit.
So you could change it to Fahrenheit and you could put it on. So it is clear for you? So now we're gonna do an exercise. Can you convert those? Do you have that application?
Sí, güey.
So the idea to do this exercise is to understand that the pressure that we're gonna put on this discharge and on the suction, it is different for the depends of the refrigerant. Could you add? I thought it was somebody.
Dice la relación de compresión. Estamos buscando.
Yeah. So if I want to put minus 25 Celsius, could you get can you give me the pressure that for 404, R22 and 410?
Vamos a cambiarlo porque yo tengo en Fahrenheit.
Okay.
Yo tengo Fahrenheit.
Sí, yo.
Minus 25 should be like 0 Fahrenheit.
Sí. Porque Fahrenheit, que estamos acostumbrados a trabajar con Fahrenheit.
Sí, no, estoy muy bien aquí.
I'm gonna help you.
Sí, ya yo lo cambio. Ok, Celsius. Vamos para allá.
Se lo pregunté.
En la succión, 22 PSI.
What is the temperature?
22 PSI. 152 PSI.
In minus 25?
En la succión.
In 404?
Espérate.
No, espera, estamos buscando temperatura.
72.
No,
It's minus 25? Yeah.
Ahora sí.
32.65.
Ahora sí, 22 PSI. Aquí.
Should be this.
22, ¿cuál lo pongo?
Yo lo puse aquí en Fahrenheit.
Oh, you could do this.
Ah,
10 psi in 404. What is the temperature that should have?
17. 17. Menos 4.7.
Okay,
34.7.
so you are using it correctly. In R22,
Pues, la temperatura.
10 psi. No, you should put 10 psi.
Bueno,
50.
15. 15.
It should be 20 minus 29.
Sí.
Minus 29.
Pero con, espérate, en vez de 22, se ocupa el 22. Ahí es diferente, con 16.
Mhm.
16 piezas.
Okay. You put it relative
El
or?
22, no, si es relativa, ahí se aumenta a 30.
Ajá.
31.
Pero si vamos ya a la relación de compresión, tenemos que sumarle 14.7
Sí.
a las dos presiones y restarla
Es correcto.
a la relación de compresión
Hazlo en 4 días.
en 4 días. Sorry, mind you, vamos.
No problem.
Menos 1.
40 menos 40.
The purpose of this exercise is that you understand that it is not the same if you put it in 4.4, R22, and 14A. Of course, normally 14A is for air conditioning, R22 is refrigeration, but also air conditioning, and 4.4 is refrigeration. But it is what I want that you see is that if we add here 448 or 449, should be another pressure.
Media temperatura y baja temperatura.
Yeah. So it is really important that depends of the temperature that you need on the chamber or in the cold room, you need to adjust the pressure to the correct refrigerant pressure pressure, saturated pressure that you have on the system. So you need to adjust it depend of the refrigerant and also the temperature that you want to need. Okay. Typical problems of installation. We discussed already some of them during the presentation, but I just want to bring it up some others that we don't put it on the list. One is high pressure on the system. It is critical that we don't have high pressure. So if we already know that the worst temperature here is gonna be 35 Celsius, that means 95 degrees Fahrenheit. So we must set the pressure switch with a differential of 15 Kelvin Fahrenheit that you said before. So that's gonna be the top. You cannot put more than that. So that's the reason that you must set it there in order to not have higher pressure on the system, because it's dangerous for the compressor. If you have a higher temperature, what you're gonna do is the refrigerant that is passing through the compressor is not cooling the compressor, and that's with the time it's gonna reduce the cycle of life of the compressor. Okay. Of course, the low pressure. Keep it in mind that the compressor cannot work in vacuum. So if you get to the condition that it's gonna work in vacuum, what you're gonna do is you're gonna provoke an arc in the electrical circuit, and it's gonna break the compressor. And also, if you have low pressure, you're gonna have liquid on the compressor. Of course, if you hear a noise on the compressor, something is not wrong. If you hear like ta 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 ta, could be that it's running backwards, the compressor. That's the reason that you need to have electrical protection there in order to protect that don't work backwards the compressor. And the other thing is that if you hear odd noise on the compressor, you need to check it. Probably you need to replace it. You need to check the pressures and it's working fine, leave it like that. But if you see that it's making a noise and the pressures are not correct, something is wrong on that system. Of course, you need to ensure that you don't have leaks on the system, because that's gonna add moisture on the system. And remember, if you're adding another fluid to your system, we saw in 10 slides before, the diagram of enthalpy of R22, 4.4, wherever. If you add water on the system, the diagram of temperatures is totally different. With water, we have at 100 Celsius, you're going to convert that liquid to vapor. That's correct. If you add nitrogen on the system, it's gonna be the diagram of enthalpy gonna be different. If you add another fluid, it's gonna be another diagram. So you cannot add, if you add multiple fluids or gases, you're gonna have a mix there, and it's gonna work bad. So it's gonna be a mess.
Es muy alto el desplazamiento. Sí, cuando uno se condensa más ácido que otro, entonces son gases no condensables.
That's correct. Yeah, because it's not condensable at that conditions, because it's not made for those conditions. So that's the reason that you must ensure that you don't have leaks on the refrigerant, because also you're gonna release the refrigerant, you're gonna fall the pressure, and you're gonna have low pressure, and you're gonna be cooling the compressor constantly. And remember, also, it is really dangerous that the compressor start cooling and running again in a short time, because it's gonna break the compressor in time to time, or also it's gonna break it, and also you're gonna increase remember, when you are turning on the compressor, it is the ramp up, it is consuming more energy rather when it's working in a certain time of time. So when you are turning on the compressor, it is the time when you are consuming more amps.
It's going to lose efficiency.
Yeah, gonna lose the efficiency of the system. Excessive ice on the evaporator. One of the critical things in a refrigeration system, it is the defrost. Because you're gonna be below the frozen temperature, you're gonna have ice on the evaporator for sure. If it is below the frozen temperature, that in Celsius is 0 degrees, in Fahrenheit is 32 Fahrenheit, you're gonna have ice. So you need to program or schedule the defrost time. Depends of the temperature on the chamber and the product that you have inside of the walk-in cooler. You need to adjust the time that you're gonna need to defrost the evaporator. It's gonna depend of if you are using 4 fins per inch or 6 fins per inch in the evaporator. Also, the humidity that you have on the cold room, etc., etc. So you must consider, if you are seeing that after you do the defrost, you still have ice on the system, probably you need to add more schedules or time schedules in the defrost time. You could extend the defrost time, or you could add an extra defrost in a certain period of time. So it is really important, because if it's still blocked with ice, you don't have a proper transfer of heat. Okay. System does not cool properly. Normally, if it is not getting the temperature, it's because one of the things, or it is selected wrongly. I mean, you select incorrectly the capacity of the condenser or the evaporator, or probably it is correct, the selection, but you select incorrectly the orifice of the TXV. What we just talk about it is that if you have a big TXV, it's not good for the system. If it is smaller, also even if it's open 100%, it's not gonna distribute enough refrigerant to the system. So that's the reason that normally you need to select the TXV with the 80-90% of the capacity that you have on the evaporator in order to be there.
Pero ya la válvula vienen ya con un margen de 1 a 3 toneladas.
Yeah, and
No
with
hay-
that tolerance.
no, exacto, solo regular y ya.
Yeah,
Divide ahí.
yeah, you could adjust the static superheat with the correct adjustment, and you're gonna get it. But you need to monitor in that. One of the things, how you're gonna know that it is set correctly when you measure the superheat. How you measure the superheat on the system? You're gonna add a sensor at the end of the evaporator, and
La presión.
if you have a Schroeder valve after the evaporator, you could put your manometer and you censor the pressure and you compare it to temperature, and the differential is the superheat. And if you see that it is constant, it is okay. Of course, should be below above 4 Kelvin. If you have below that, it's not good because it's really dangerous. Because probably you're gonna have a liquid on your system. So you must be above 4 Kelvin and constant. You must see like 7, 10 Kelvin is good. Okay. Defrost cycles do not start or are ineffective. That's one of the points that we already discussed. Compressor makes strange noises. I can tell you one of the things could be that it's running backwards. Other thing is that probably one internal component is already broke. So it is mumbling and vibrating inside of the system. At the end of the day, it's gonna break that compressor. So you must replace it at the end of the day. Compressors do not shut off. That's important. When you have a compressor that is not turning off, what does that mean? What do you think is the reason of that? Do you have an idea?
Si lo dicen en español, lo entiendo un poquito más.
Compressor do not shut off means, I'm gonna translate to Spanish. Que el compresor no para.
No para nunca.
Alcanza la temperatura.
Cuando no para, significa solo una cosa, que la unidad está mal seleccionada. Es decir,
Nunca llega a la temperatura adecuada.
nunca va a llegar a la temperatura.
Y eso es problema, porque eso puede frizar el evaporador, una serie de cosas que, pues, si estamos hablando de cooler, cooler tiene un time, siempre va a parar, pero nunca va a llegar a la temperatura.
Nunca va a cortar por
Nunca va a
temperatura.
por temperatura. Exacto.
I'm going to switch to English to transfer to that. What we are talking about is that normally when the compressor don't shut off, means that normally the condensing unit or the evaporator is smaller than the heat that we need to remove. So the compressor want to try to get to the set point, but because it's really big, it's not possible to get the temperature that we want. So it's gonna be on and on and on all the time because we wanna try to get to that temperature, but it is bigger than the capacity of the condensing unit of the evaporator. So we need to check if we selected correctly condensing unit, evaporator, or the TXP.
Sí.
Okay. And failure due to poor vacuum, that's critical. We need to do vacuum before the system. Vacuum, yeah. Because one of the things is we're gonna have moisture on the system, not condensated gases also on the system. We're gonna have microparticles that it could get into the small orifices that we have in the system. It is raining.
Yeah.
And so it is really critical, and also to remove all the dirt that we have when we are doing the bracing and the installation of the system. So we must ensure the proper vacuum of the system. That's gonna give us extra extra life on our system. It is really, really important that thing, because when you are sensing the temperature on the bulb of the TXV, or when we have the pressure that we are sensing on the pressure switches, we are sensing the pressure or the temperature of the refrigerant that we have inside. If we have other gases on the system, it's gonna give us a headache, and at the end of the day, gonna break the compressor. Can you show me the mouse pad, or can you click it? Also, I'm gonna share you one of the small errors on the installation. This is one of the errors where, what do you think is wrong here? One of the things is the pipes.
Ruger.
The gas.
The houses.
Yeah, it is houses for refrigeration is not correct.
No.
So it's not good. This is a real life. It's real life. What do you think is wrong there? Yeah. One is wrong ventilation. The other thing, it is in the, it's a drain, so it's gonna fall all the water inside of the condensing unit. What do you think is wrong there?
The ventilation is restricted.
Yeah.
For service.
Yeah, the problem is that it's gonna get there and throw it there, and it's not enough room, to release and to absorb the air of the ambient temperature. And you're gonna increase the high pressure. Yeah. And you're gonna block the compressor. You're gonna turn off the compressor, and you're gonna break it at the end of the day. So it is critical to have enough room to the condensing unit and also to the evaporator. But for the condensing unit, you have enough room to absorb and release the heat to the ambient temperature. This is some of the situations that we normally see during the installation that is not wrong, or is not a best practice. One is to not consider recommended air circulation space. We need to have enough room, at least 3 meters or of space, in order to do a proper transfer of the heat. Also, if you see that is in a place, for instance, normally they put it inside of a kitchen. You have a lot of grays and a lot of dirt. You need to do a proper maintenance of those condensing units. That means to clean it frequently, at least one time per month, or depends of the situation. But you need to do maintenance to that system in order to clean the condenser. Because if you have a lot of dirt in the condenser, you're going to increase also the pressure on the condenser. Refrigerant. Dirty the condenser is also, you could fix that with proper maintenance. High ambient temperature. Remember, we're gonna see it later, but it is critical to select the condensing unit and the evaporator in the worst conditions possible on that area. Whenever I receive a feedback from my customer that, okay, I'm gonna install a new condensing unit in Arizona. Okay, in Arizona, I'm gonna Google, what is the worst ambient temperature there? Oh, it's gonna be 110 Fahrenheit there. Okay, so I must know that I'm gonna need, for condenser, I'm gonna need 125 Fahrenheit in order to transfer the heat from the from the cold room to the ambient temperature. So I must select the correct condensing unit accordingly to the worst scenario that we're gonna have on that installation. Okay. So that's the reason that we need to select accordingly to the depends of the city or probably the condensing unit is gonna be inside of a room and it's gonna be climatized. So if that is the case, you're gonna must select it accordingly to the temperature that you regularly gonna have there. Okay, high thermal load. Another thing that we see in the market is that you're gonna select, for instance, this is a cold room, and you put, like a bar here that should be loaded, this room till here. But when you enter 2 years later, it's gonna be full, or totally full or crowded and totally overweight. So normally what I did or what I do is that I do like a regular weight and oversize, because we know that in some installations the people that works on that kitchen, restaurant, whatever you may have, they passed, the regulations or the requirements that you're gonna do. So you need to consider that extra heat that you could have on the room. I'm gonna share it later. High superheat, that means that you have if you have a high superheat, you could damage your compressor.
Se calienta.
Ya, se va a calentar el compresor y va a tronar. Se van a degradar los componentes internos y se van a quebrar, tarde que temprano. They're gonna break all the internal components because they're gonna damage internally all the elements that we have internally on the compressor. And refrigerant overload. Normally, we select a condensing unit with if you're gonna install the condenser or a condensing unit, 20, 25 meters in the distance between the condenser and the evaporator. If you have a longer distance, you need to add more refrigerant to the system.
Ok, pero ¿qué cantidad por cada pie de tubería?
Depends of the situation, because if it is horizontal or if it is vertical. We're gonna discuss about it later. We have a software that could help you to maintain, because you need to have at least a velocity, a minimum velocity or speed on the pipe of the refrigerant in order to ensure that you are returning oil to the compressor, because it is critical to the compressor to be lubricated, and also that to turn back the refrigerant. So we're gonna see it later in the next slide. Okay, this is another thing that we have, that low pressure in the cooling system. What is normally when we have a low pressure in the cooling system could mean some things. One is wrong selection of the thermostatic expansion valve. That means that it is a really small valve that you put on. And what you are doing is that you are supplying a small quantity of refrigerant to a big evaporator. So probably the evaporator is 65,000 BTUs, and you are putting a 30,000 BTU TXB. So it's not gonna be enough. So even that all the valves have like they call it surplus of capacity. That means like normally like 10% extra capacity of the TXV is not enough. It's not enough. So if it is small, you're gonna have a low pressure. Cloud filter, that means that the filter it is blocked because it already absorbed all the humidity and probably get a lot of dirt from wrong installation, and it's blocked. And what you're gonna have is after the filter dye that is still in the liquid line, you're gonna see like frozen all the piping after that, and you're gonna have vacuum after that because it's passing through a small quantity of refrigerant. You are doing like a TXV in the filter dry. So that's not good, and you're gonna break the compressor also. Damage solenoid valve. That means that when you are trying to turn it off for because you're gonna turn off to turn on the solenoid valve and make look like vacuum after the evaporator, and you're gonna close the compressor because you're gonna drop the pressure on the suction side. If not close the solenoid valve, you're gonna have
pull down.
Pull down, and the system is gonna still working, and never cut off the system.
No, ese dispara por pull down. Si la horno se cierra, pull down.
Yeah, but normally it's open.
Sí, normally open.
Yeah, so the valve is normally open. So if it is damaged, it's gonna be open all the time.
Nunca se queda abierto.
And the compressor gonna be up and running all the time and never gonna cut off.
Cuando cierra y si queda media abierta, es un problema también.
Also, yeah. Normally the spring, it could damage and could be like in a wrong position, and it's gonna be half open, like you say. Lack of refrigerant on the system, you're gonna see it. You're gonna see bubbles on the side glass. If you don't have enough refrigerant in the system, you're gonna see a lot of bubbles on the side glass. So that's one of the ways that you notice that you don't have enough refrigerant.
Ve la cantidad que ha pasado.
And also you're gonna see a small low pressure on if you measure the pressure on the suction side. Low superheat, if it is below 4 Kelvin,
It's bad. Un golpe líquido de morder.
you're gonna see the compressor broke. Because if it is a scroll compressor, in Mexico we say the scroll compressor is really chismoso. If it is, it is so transparent. The scroll compressor, it is delicate. So if you have liquid on the suction, you're gonna break it.
Es un problema. Me mandaron siempre de entre 8 o 10. Siempre hay que tenerlo, por lo menos yo, en particular, dejarlo en 8 a 2. Aproximadamente, no bajito, como decía.
Superheat is something that you must have in order to ensure to protect the compressor. So it is better to be 8, 10 kelvins and above. Not so high, but above that. Okay. And one of the things that we already saw, that is incorrectly adjusted pressure switch. Depends on the refrigerant, you need to adjust the pressure switch. If it is 4.4, 4.48, 4.49, or the new ones, the A2Ls, 4.54C, A, whatever you may have, R22, you need to switch it. I need to adjust the pressure in the pressure switch. Okay, it is really, really important. Normally, the pressure switches that we put on our system, it is, for instance, for our condensing unit, we have a pressure switch that is for multi-refrigerant. So for 454C, that is A2L, or 44 or R22, we set for the pressure switch, it is set by default. Okay, the only one that you could adjust is the KP that is in the next slide.
¿Qué por ciento por arriba? Por encima de la temperatura sí,
The ambient temperature, yeah.
sí, esa de 30 más o menos.
Mhm. Well, this is the Danfoss pressure switches. This is electronical pressure switch. This normally we put it on the high pressure.
Y ella viene seteado ya, ¿verdad?
Yeah,
No se
in
cambia.
order to protect the compressor.
Okay.
So that one we put it electronical in order that they cannot. Nobody can change it. But even though you could put, we put this one on the suction, on the low pressure, but you could buy a dual. We call it dual. There is suction and also high pressure. Okay, so you could put an extra protection that is mechanical, right? And it working like cool in, cool out. If you have you set a pressure that is gonna turn off the compressor, and when going down, well, depends if it is suction or high.
La diferencia es 10.
Yeah, you set it at 10 differential at 10 delta T 3P, I mean, and with that differential, it turns on again. This is how it works. It is like a spring, detect the pressure and turn it on and turn it off. Okay. Well, this is how thermostat works. With an electronic device, what we do is that we sensing the temperature and we do the cool in, cool out. We connect it to the solenoid valve and we could turn off the circuit when we turn on the solenoid. And we regulate accordingly when we get the temperature that we want on the cold room. It's gonna turn on or turn off. Correct? Questions? The pressure transducer. We already saw that we have subcooling and superheat, right? So we need, in order to get that information, we need to transform the pressure that we have on the system to a value that we can measure in an electronic device, right? So in order to transform or to do the superheat or the subcooling on the system, we need to measure the pressure and also the temperature. So the temperature, we measure that one with a PT1000 or with a sensor, but with the pressure, we need a pressure transmitter. So for instance, we only talk about TXVs, but in some cases, are some customers that they want a more efficient system. We already talked that the TXV, what the TXV do is that accordingly of the demand of the heat that we have on this room, it's gonna be open or closing, adding more refrigerant to the evaporator or reducing the amount of refrigerant. With the electronic expansion valve, it's gonna be pretty similar, but it's gonna be faster. Okay, so that means that if he already gone the room, so the valve is gonna detect that there is not enough people here, and it's gonna reduce the amount of refrigerant. So it's gonna be faster, but you need this kind of sensors, a pressure transducer to detect the pressure and convert it to temperature and measure the superheat, and the PT1000 or the sensor that we have in order to do the superheat and open and close the valve in a faster way. That's the reason that For instance, if you have a fixed orifice, you're gonna have efficiency of whatever you want. If you add a TXV, you're gonna have like a 30% of efficiency of the system only to add a TXV. And if you add an electronic expansion valve, you could get, an extra 30% of efficiency because, the system is gonna act in a faster way than a mechanical way. Okay? And this is how you install it. This is a Danfoss electronic expansion valve. It is by steps. We call it the step valve. What we have is we put the sensor, a PT1000, at the end of the evaporator, and we put a transducer at the end. So we measure the temperature and the pressure. The controller transform it to temperature and measure the superheat that we have. And depends on that, we're gonna open and close the EEV, okay, the ETS that we call it Danfoss, okay. So it's gonna be faster and more efficient. But the concept in the TXV is pretty similar. Yeah. Okay. You're gonna do the same. What you added in the TXV is that you are putting, equalizer here to detect the pressure, and you're gonna get that pressure into the chamber of the TXV, and with the bulb of the TXV, you are sensing the temperature. Because in that bulb, you are adding refrigerant, and when you get to the temperature, that refrigerant that is inside of the bulb expanded and put a pressure on the diaphragm of the TXV and push, the orifice and open and closing the valve. Wow. Okay. Symptom of a faulty thermostat expansion valve. One of the critical things that we could have is high pressure on the low side. That means when we have a really high pressure, that means that we are opening a lot the TXV, or that we have a big thermostatic expansion valve. So it is really big. Probably we did the opposite. We have like you said, we select a 60,000 BTUs TXV because we select for the condensing unit, but you have two evaporators and you put it on only one evaporator. So even if the TXV is trying to close the valve, it is 30,000 BTUs if they giving you the half of the capacity. So it is too much refrigerant that you're adding. So you're gonna have a high pressure at the end of the evaporator, right? Very high superheat. That means that could damage the compressor because the compressor is not gonna get cool, and it's gonna be very risky. Normally, when you have a high superheat, that means that it is small. It is small orifice on the TXV, and you need to change it, or probably you need to adjust it. Okay, high temperature on the compressor. That means that you have a high superheat. Okay. Incorrect temperatures in the cold room. That means that when we do we measure the pressure on the cold room, probably we adjusted incorrectly.
Wow. Mucho factores.
Yeah.
Okay.
Probably we say, okay, the delta T of the evaporator is 6 Celsius, but no, that evaporator is 20. And you only add 6, and you're gonna get a different temperature on the evaporator, or the orifice is incorrect, so you need to adjust it. And when the valve is too close, that means that is also as big TXV for that one, because you're don't gonna have enough superheat on the evaporator and never gonna open the TXV. Okay. Also, when it's closed, could be two things. When the bulk charge release the refrigerant, the valve is gonna be closed.
Close, se trans.
Yeah. Because you're gonna measure the ambient temperature of the pressure. You're gonna detect the ambient temperature. So it's gonna be really high and you're gonna close it. So that's the reason that if you see that it's blocked, it means two things. One, that is blocked because you have a lot of dirty in the system and it blocks it inside of the orifice. Or when we manipulate the bulb, we break something internally. That's the reason that it's really, really important when you are adding a TXV and you're gonna brace it, put a bulb strap, put a wet rack on the TXV in order to cover the internal elements of the TXV. Because if you damage the diaphragm that is inside here, it's a really small element. If you damage, you could expand it or could break it, and you could release the refrigerant that you have on the top part of the TXV, and you're gonna release it through the diaphragm to the TXV, and you're gonna lose the pressure of the bulb that is here. So here you're gonna see you're gonna have refrigerant until the bulb.
Siempre va a mantener, ese bulbo siempre va a mantener la válvula abierta. Si se parte,
Yeah.
se cierra la válvula.
Yeah. If you release the refrigerant there, it's gonna be closed, that bulb. So if you see that, you need to change the TXV.
The TXV.
Yeah. Yeah. Somebody probably, and normally you're gonna break normally here, or probably sometimes happen. You are bracing and you pass the flame through, to the diaphragm and you burn it and you break it. So it's really important that when you are bracing, first you leave it like it is, put the wet wrap to protect the TXV. You do all the bracing and then you move and put and set the bulb at the end of the evaporator. And as we mentioned, put it in a position of 9, 12, or 3 if you see the pipe as a clock, right?
¿Cómo estamos de tiempo ahí?
Son 11.
¿Qué te falta?
Del catálogo, ¿me brinco al catálogo?
No, como vaya. ¿Cómo estás de tiempo? Nosotros tenemos el tiempo.
¿Cuánto más falta?
¿Cuánto más falta?
Usted dígame, le doy 30 minutos.
30 minutos, está bien.
¿Sí? Ok.
Sí, encuentro el baño.
Dale, ¿quedamos un break de 5 minutos?
Va.
Vamos a hacer un break de 5 minutos. Let's break for 5 minutes.
Ok.
¿Qué te falta ahí?
Ya nada más el catálogo. Pero me lo aviento rápido. Nada más.
Acá. Y afuera le vamos a mostrar las unidades.
Sí.
Listo. Mr. Senior, how are you?
Bueno.
Glad to see you.
Always.
Algo,
¿Vale?
Entonces, cerrando.
Entonces,
Algo que es lo que falta ahí por las máquinas, ¿verdad?
en las máquinas, las ventajas, los componentes internos. La verdad me lo voy a chutar muy rápido. Realmente nada más mostrar los componentes que tenemos en el sistema.
Sí.
Pero básicamente es las ventajas que tienen las unidades contra la competencia y qué componentes tiene, diferenciales y qué capacidades tenemos, etcétera.
Sí.
Pero sí quería hablar pues, de todas las buenas prácticas que debemos de tener al momento de instalar, ¿no?
sí, yo instalé una con Luis de esos Danfoss y está muy completa, está muy buena. Tiene succión como ellos, bolsa para ellos. Una unidad de 3 caballos, súper, bastante buena.
Sí.
Mi pregunta es que esas máquinas tienen un condensador de aluminio,
De microcanal. Ajá.
microchannel, que nosotros decimos.
Ujú.
Y esas máquinas se le puede recuperar el refrigerante dentro de ellas, no, pero
Al condensador.
condensador.
Sí, pero realmente el condensador es mucho más pequeño porque no necesitas en aleta y tubo.
Ajá.
Tú tienes el tubo es grande, ¿no? Y ahí pasa bastante refrigerante. En un microcanal, no sé si alguna vez has partido un microcanal, es como una aguja.
Es como una agujita, ajá.
Entonces la
Como
carga de
filtrar
refrigerante es
cuatro.
muy baja, pero sí puedes extraer,
Un
sí,
porcentaje.
sí, un bastante porcentaje. Si le pones válvulas bola o a, a la entrada y la salida, lo que puedes hacer es cerrar una válvula, arrancas el compresor para que succione todo el refrigerante y luego la cierras y así lo dejas hermético y ya quitas el microcanal y lo reemplazas, ¿no?
Sí, te pregunto porque, ¿qué es lo que pasa? Que nosotros vamos a ver si yo tengo varios locales de refrigeración.
Ujú.
Y entonces esas máquinas me di cuenta que es como las aire acondicionados. O sea, generalmente cuando tienes una solenoide,
Ujú.
pues, como dice, la solenoide cierra con la temperatura o X y defrost.
Ujú.
Entonces recupera un porcentaje, o sea, recupera el refrigerante de la línea líquida del compresor. Pero cuando las solenoides están arriba en el condensador
En el evaporador.
en el evaporador, o cuando están arriba en lo que es la salida del condensador, en esas máquinas, entonces el refrigerante lo tiene que recuperar lo que va después de la solenoide hacia abajo, en este caso, y
Ujú.
lo que está en el evaporador hacia arriba. Entonces, pregunto si el porcentaje que recupere todo eso.
Sí.
Porque como un microchannel, más o menos una máquina esa se puede llevar, no sé, 15, 12 libras, un versito.
Sí, lo que sí te puedo decir es que, por decir, comparado contra uno de aleta y tubo,
Ajá,
tiene 30% menos de refrigerante que uno de aleta y tubo.
una letra, sí.
O sea, con 30% menos de refrigerante te hace la misma función, la transferencia de calor.
Sí,
Entonces, esa es la ventaja del microcanal. Entonces, tiene mucho menos refrigerante
sí, claro.
que una aleta y tubo. Entonces, es básicamente igual, lo puedes recuperar de esa misma manera que lo haces con el de aleta y tubo. Le pones una válvula de servicio a la entrada y a la salida, arrancas el compresor o la válvula de vacío,
Ajá.
succionas
Ujú.
y extraes el refrigerante y cierras antes del condensador. Y así extraes todo el refrigerante si lo llegaras a tener, ¿no? Ujú. Eh, pero sí, digo, el chiste es nada más que le agregues válvulas de servicio a la entrada y la salida. Eh, Nuestra unidad condensadora tiene válvulas de servicio
Sí,
en
ya tienen
la línea de líquido,
ujú, ajá,
bueno, en el recibidor de líquido,
sí,
y también tiene
en la succión
en la succión, así es,
compresor.
en la succión. Entonces, eso es lo que pudieras hacer, cerrar, ir cerrando las válvulas de servicio y estar ir extrayendo el refrigerante.
Sí, sí.
Digo, obviamente se te va a ir algo de carga, pero tú tienes la ventaja de que tiene válvulas de servicio, las de la competencia no tienen, salvo la línea de líquido y la línea de extrusión, las dos tomas que salen.
Sí.
Eso es lo que ellos ponen normalmente, como si fueran de mini split.
Ujú.
Pero nosotros tenemos tanto la entrada del recibidor, en la salida y en la succión del compresor.
Unos compresores, sí.
Sí,
Está ahí.
en lo de entrada y salida del compresor.
Sí, me encantó. La semana pasada entramos uno y yo la vi y dije, wow, está súper completa la
Porque
máquina.
lo hacemos de esa manera para que también quieres cambiar el compresor, cierras las dos válvulas, sacas y pones, ¿no? Mucho más fácil darle servicio. De hecho, en Latinoamérica tenemos un entrenamiento donde, a ver, órale, reemplacen aquí el compresor, ¿no?
Ajá.
Y le podías cambiar en menos de 5. De hecho, poníamos un reto de que lo hicieran menos de 5 minutos, ¿no? O sea, había gente que lo hacía en minuto y medio, ¿no?
Sí.
Esa es la ventaja de poner las válvulas de servicio entrada y salida del compresor. Hay algunos que te dicen, no, pero yo quiero seguridad porque así pongo soldar. Bueno, y se ganan
Sí,
unas por otras, ¿no?
sí, es que así es mucho mejor porque no toca el refrigerante ni nada.
Sí,
y mantiene todo completo adentro.
sí, va.
Sí, está muy bueno, de verdad que sí, me encanta.
Sí, sí, sí. Sí, al final del día, pues lo que tratamos de hacer es hacer una unidad eficiente,
Ujú.
pero también que sea práctica para ustedes para servicio, ¿no? La parte de, porque sabemos que las principales cosas que vas a cambiar es el filtro, por eso también es de
Es lo que hago.
el roscable, para que tú seas fácil. Necesitas cambiar el filtro, los enrosco y tiene válvulas de servicio también para cerrar, para
Ujú.
cortar ahí el refrigerante, la mirilla y pues, en el compresor y en el recibidor, ¿no?
Sí.
Hacerlo de esa manera. Obviamente también la caja eléctrica poner suficiente espacio para si quieres agregar un
Sí.
controlador electrónico, etcétera, etcétera. Y otra de las ventajas ahí que tenemos es que le pusimos un switch de presión para que también, acorde la presión que tienes en el condensador,
Sí.
tenga tres velocidades el motor. Entonces, sí, sí. Entonces tiene tres velocidades, va a estar jugando dependiendo de la
Temperatura y todo.
temperatura exterior que tengas, va a aventar más presión o menos presión,
Ujú.
y así hacer la transferencia de calor,
Oh,
dependiendo del ambiente. Puede ser que a lo mejor en la mañana estés a 10 grados o a
ujú.
70 Fahrenheit,
Ujú.
y en la noche, perdón, en la tarde estés a 90 y luego vuelves a bajar a 70. Entonces, para ahorrar energía, el motor baja su velocidad
Sí.
y con eso haces la misma transferencia de calor. Porque ya no necesitas 90 grados, necesitas 80, ¿no?
Sí.
Entonces va a estar regulando el motor y ahí ahorras energía, y esa es otra de las funciones que tenemos. La otra es lo del microcanal, ¿no? Al final del día es menos refrigerante.
Sí, no, fíjate, sí, no está bueno, me encanta.
Sí.
Y de todas maneras, yo tengo tu tarjeta, cualquier cosa yo te
Ujú.
llamo, o lo que salga, que me gustaría meterme por esta línea, la verdad que sí.
Sí, bueno, lo que necesites. Y si tienes alguna duda de seleccionar una unidad, con todo gusto,
Sí,
eh,
ya, mira, cuadrado y todo.
les voy a mandar. Puse ahí muy rápido de cómo hacer una selección de cuarto frío en Pulse Selector 2.
Ujú.
Es bastante sencillo. Yo al final se los voy a mandar la presentación en PDF para que la vean.
Ujú.
También es un software que está en internet,
Sí,
que se llama Cool Selector 2.
ajá. O si cualquier cosa, si tú quieres, en mi número de teléfono, me la pueden enviar ahí, yo estoy
Ok, va,
sí, y él me envía eso ahí también, cualquier
va.
cosa.
No, no,
Es
con
muy
gusto.
importante.
Claro. Sí, sí, sí. Y es ahí una forma de hacer la selección de forma correcta, porque en base a los requerimientos del proyecto, estás haciendo la selección. Normalmente todo el mundo lo que hace es tenía instalado una de 5 HP, pues le pongo la misma de 5 HP. No, lo que deberías de hacer es mejor seleccionarla acorde a lo que
Aquí el cuadro que tú tienes y todo lo demás, y las necesidades.
el tamaño, en qué parte del ambiente está, en qué país, en qué ciudad. La altura también es importante,
Ujú.
si está adentro, afuera de un cuarto, etcétera, ¿no? Todas esas condiciones, bueno, tenemos un software que tú puedes poner toda esa información y te saca cuál es el calor que necesitas remover, y acorde a eso seleccionar la unidad, el evaporador, calcular el tamaño de la tubería,
Ujú.
para tener un flujo constante para retomar el aceite y todo eso.
Sí, pues,
Sí, pero eso lo vas a ver ahí
sí.
en el curso electoral.
Bueno, entonces estamos, oye,
Entonces,
va, si me gusta, un poco más por un break. Yo te llamo ahora, ¿no? Claro, pues, mira, tú te estás hablando. Oye, entonces, gracias. Vamos a llegar a donde sea ahí, me llama.
Perfecto.
Claro, pa, no puede estar solo en el camino. Sí, sí, o sea, ¿dónde lo debe hay que conocer?
Ok,
Hablando con Juan hace años.
Ah,
A él, por la.
Sí,
por la verdad,
I'm gonna start quickly because I know that I already extended the time, but I'm gonna try to be the most quicker that I can. I just want to show you. Mouse.
Creo que no está compartiendo.
We're not. Oh, stop share. Your screen is pause. What do you mean? Oh, resume. Okay.
Ay, pues la agregada para que es un buen.
Are you seeing my screen now? Yes. Okay. Perfect. Okay. So why not working? I'm gonna sit again. Okay. So we already talked about all the components. So in the condensing unit, we have at least two of the critical components, that is the compressor and the condenser. So we have it inside of the condensing unit, and in the evaporator, normally we add the other two critical components, that is the TXV and also the evaporator, right? So Danfoss offer the solution. Well, this is the main application that we use the condensing units of refrigeration. We could use it in HoReCa, that means hotels, restaurants, and catering, food service. In industrial, that is big warehouses, but cooler warehouses. Critical storage of pharmaceutical storage, and of course, the cold chain. Yeah, remember that in this time, all the big cities must provide all the food. So you must do the cold chain, since you get the food that could be on the field, on the farms, until we get it to the house of every house that we have in the world. So we must have refrigeration in all that process. Okay. So this is one of the typical applications. I'm not gonna go deep in this. We already know the different application that we have in the transportation, on small freezers and coolers. In these kind of applications, in the ice machines, in the ices, in the freezers, coolers, glass door merchandisers, etc. Normally we use fractional condensing units. Why we call it fractional? Because it is the horsepower of the compressor is below 1 horsepower. That's the reason that we call it fractional. Danfoss has from 1.7 to 1.5 condensing units in that application. We just, like I spoke before, we just launched the R290 condensing unit, that because we know that all the market, it is since 6 years ago, like Coke, Walmart, Heineken, Pepsi, and some others, moved from 4.4 or 134A to R290. So that's the reason that we include this in our portfolio. And that's one of the condensing units that we just add. For cold rooms and walk-in coolers, and for milk tanks, we have. Yeah, enfriador de leche. Yeah. So remember, we are on the cold chain. So we must ensure that we have the proper temperature to maintain and conserve the food. That could be milk, could be meat, fish, you name it. Pharmaceutical. So for all those, we have two types of condensing units. We have the indoor units, if you put it inside of a building, or the outdoor units, that is are in the ambient temperature. And also in that option, we know that, for instance, in US and in Canada, in the north part of US and in Canada, we have low ambient temperature. So we have also a solution for that. I'm gonna explain it later. So we have also a solution that is for the outdoor units. This where we build our condensing units of Danfoss. We have production for the fractional condensing unit. We build it in Atlanta. For R290 fractional, we build it in Monterrey, Mexico. And for the indoors and the outdoors, we also build it in Monterrey, Mexico. Okay. We also have factories in Brazil for the Latin America market, and in France and Italy and Czech Republic for Europe, India for Asia Pacific, and Thailand we have a R&D department. Okay. This is the unit that we have. These units, I mean, this is the one, the R290, but this unit, the blue ones, is for Latin America. So if you go to Puerto Rico, to Mexico, Brazil, Colombia, so on, you're gonna see these blue units. We build it also in Monterrey or in Brazil, depends on which part of Latin America you are. And also we have this extra portfolio. So for instance, I don't know, you never know, but if you're gonna install a project that are gonna be in Europe, also we have 50 hertz condensing units. Of course, here we offer to Galpa 60 hertz and 150 and 220 and 440 for the North American market. But I include this slide in order that you could see that also we have a solution for other markets. Okay. Also, we just launched the CO2 condensing unit. These are the units that we have for North America. That is the fractionals that we just launched, the R290 and the A2L condensing units. The indoor units that are certified for A1, the process, the plan is to have in A2L at the end of the year, because the new regulation gonna move to that refrigerant. And the outdoor units, that is the units that we have for that is the complete product or the premium product for the outdoor units. Evaporators that could do the match with our condensing units. One of the things that I want to mention here is that this unit, since this month, is gonna be multi-refrigerant. So now we're gonna add the A2L refrigerant. So if you have a project for A2L, we also have condensing units for that refrigerant. And the plan is for in the Q3 of this year, we're gonna have also the evaporator for those refrigerants. Okay. This month also we just launched the 20 HP condensing unit for CO2. And the plan is for next year, we're gonna launch also the 5, 10, and 15 HP. Okay. Oh, okay. Good. You wanna do? Oh, okay. So this is the regulation that we have. Depends of the application. The regulation of DOE in North America and in Canada is that for food retail, for standalones and freezers and coolers and glass door merchandisers, we need to have GWP refrigerant below 150 GWP. So the only option that we could have is the R290, or could be also the CO2. We used to have it, I don't know, like 10 years ago, Coke was the only one that has had units of CO2, but after 2-3 years, they decided to move to R290. So most of them, they already moved to R290. So that's the reason that we launched that product. For cold room, It's supposed that this year must move to A2L, but a lot of the big companies and the ASHRAE and ADI are pushing to the government to stop it, to put it on hold until the market is prepared. Because now we don't have enough capacity for the current suppliers of refrigerant to supply that refrigerant, and also it's really expensive, and we don't have enough in the market. So that's the reason that is all the big OEMs are pushing the government to say stop and to put it on hold, at least until we see clarity on that. But Danfoss is prepared for that. So we know that some end users are pushing to move to A2L. So if you need some projects for that, we have. And for process chillers, we know, data centers is growing faster across the region. Yeah, they are building a lot of data centers across the country, in Canada, in Latin America. So also you could use the outdoor unit and the indoor units. There we don't have a regulation. We could use condensing units with a refrigerant of 700 GWP. So we could use whatever unit you need, and also the refrigerant that you could use. Normally could use 410A, or the new ones are R32 or 404, 134, etc. Oh, sorry. And for the supermarkets, we're seeing that they are moving to CO2, but also they are moving to A2L. So it could be the outdoor unit or the CO2. So that's the reason that we have both in order to fulfill the demand. One of the things that the advantage that we have for the condensing units is that the 90% of the components that you see in the condensing unit, we're going to see it shortly physically, it is Danfoss components. So Danfoss build the components and also assembly the condensing units and the evaporator. So if you need a replacement for that, our distributor has all the raw materials and all the spare parts for those, because you only need one supplier for that. So that's the difference if you compare versus our main competitors, because normally they assemble the condensing unit or the evaporator, but they don't build the components, right? So we have compressors, we have different kind of compressor, hermetic, scroll, semi-hermetic, variable speed compressors. We also have the microchannel, the pressure switches, the ball valves, the side glasses, filter dryers, pressure switches, controllers, and solenoid valves, and thermostat, mechanical or electrical, and of course the evaporators. For the outdoor units, this is the range that we have. We already discussed about the fractional condensing units, that is 1.7 to 1.5. With that, we have the Huayi compressor. It is not Danfoss, because we used to have a fractional compressor, but we already sold that division, but we still have like an agreement with Huayi, and we build the condensing units of those capacities with that specific compressor. For 1.5 and above, it is Danfoss compressor. And depends on the unit. Now we are discussing the outdoor unit. For 1.5 HP is a hermetic compressor, and from 2 and above, it is a scroll compressor. So we have it in medium temperature and low temperature. So we could say between 28 to 20%. Only in the refrigerant charge, we are saving 20%. You don't need to charge a lot of refrigerant on a regular installation, because it is the microchannels, it is like 30% of the volume inside of the condenser is more small. And you're gonna see it physically. If you compare versus a feed and tube condenser, it is, could be like, I don't know, 15, 20 centimeters versus, I don't know, 5 or 7 centimeters of thickness of the condenser in a microchannel. So that reduces a lot in space, weight. It's easier to carry on.
Y la eficiencia, la misma eficiencia.
It is actually is more efficient with a small volume. You do the same transfer. So that's the improvement and that's the efficiency of the condensing unit. And also you need to charge less refrigerant because the volume, I don't know if you have you ever crossed or cooked a microchannel condenser. That's the reason that they call microchannels, because the channels are micro.
Sí, tiene más fibra,
it's like
pueda transferir más rápido el calor.
And as you may know, if you have turbulence inside of the condenser, the heat transfer is much better. So if you have a smaller pipe, you're gonna have turbulence inside of the condenser, and you're gonna do a better transfer. And also, it's aluminum. It's 100% aluminum, and the aluminum is a really good solution of heat transfer. So it is really efficient. I used to my old role was to be responsible for OEMs, and what I could tell you is we already introduced these condensers to big OEMs, like not only in air conditioning, also in refrigeration, and they are saving around 30% of efficiency only to change fin and tube versus a microchannel.
30%.
Yeah, and also in charge, for instance, for the coolers, for the glass door merchandiser, they reduce like 20 or 28% of the charge of the refrigerant that they're gonna need. So that's one of the main benefits of the microchannel. That is, the volume is gonna be smaller, and also the weight, because the condenser, the fin and tube condenser is really big. Yeah. For the evaporator, it is pretty similar to our competitors. We have low profile, medium profile, and high profile. Depends on the size of the walk-in cooler or the cold room. Normally, the 70% of the volume, it is low profile. We have 50%, I would say, from 1 HP to 5 HP, 7 HP. Normally, that kind of evaporator, we have it in the low profile. Could be also some medium profile. And from medium profile, we have 4 or 6 fin per inch. That means, depends if you need it for low temperature, you could change the fin per inch that you're gonna need on the evaporator. Also, we have in all the versions, we have air defrost or electric defrost. Okay, and it's gonna start also from 1.5 HP condensing units and above. This is the advantage of the outdoor units. It is easier to take off the housing of the condensing unit in order to set up the KP or the pressure switches. Also, you have the connections on your left side of the condenser. The standard footprint, because it's microchannel, it is smaller. So it's gonna be much smaller. The footprint of the condensing unit. You're gonna have service valves in all in the inlet and outlet of the compressor. So if you want to change the compressor, it is really easy only to close the service valve
Yes, easy.
and replace it.
Fast.
That's one of the reasons that we put it on that way, in order to do it super easy to do the service. Also in the receiver and in the
Accumulator.
accumulator of the system.
Oh, very good.
Also is super easy. This is the indoor unit. It is super easy to identify the difference between indoor and outdoor. The indoor it is black, and of course don't have a housing.
Black or blue?
Black or gray.
Or blue?
Are you talking about the compressor?
Oh, sorry. Okay.
Yeah, because the unit it is black or it is gray. So the gray one is the outdoor because has the housing, and the indoor unit it is black and don't have any housing. Again.
No, el gris es tapado
Mhm.
y el negro es abierto.
Y también hay un azul.
Y hay blue también.
The blue one. The blue one is for the Latin American market, and you could sell it also everywhere in
The
Latin
only
America.
thing with the blue one is that doesn't have UL
Yeah,
certifications.
Ah,
because they don't. Yeah, the Latin American market don't need UL. Okay, so but all the components are certified, of course, but we don't certify the condensing unit in the UL.
Disculpa que te interrumpa.
Yeah.
No sé si tengas algo más que cubrir. ¿Quieres que veamos esto afuera y así avanzamos?
Ok, sí, para mostrar ahí los componentes. Va.
Así matamos dos pájaros de un tiro.
claro.
So in some countries, it's gonna be more efficient rather if you compare it versus scroll compressor.
Yeah.
So that's the advantage of this scroll, I mean this hermetic compressor. Of course, in the highest point of efficiency, much better, but you know, this one is much you know, the range is wider, and also the efficiency is similar in almost all the conditions, right? Also, like I said before, it is more robust. As you can see, the advantage of all the condensing units of Danfoss, we have you know, service valve in the inlet and well, discharge and suction side. In order to do it super easy to do service. So you only close it and you could replace it. And of course, in the filter dryer of this one, shouldn't be, doesn't have it. But in this one, well, this is not ours, but in that one, in the outdoor unit, we have it here, and you can see it is also well, in the other ones it's rod lock. In this one is a threaded valve. I mean, there. Yeah, as you can see, it is easy to do service also. Okay. Yeah. It's not cable. It is threaded, and it is super easy. You only close the valve here in the service valve, and you could easily replace it. Also, it is super easy. You only this tab, and you could adjust the table. Yeah, this is the smallest one. It's 1.5. Yeah, this is medium temperature. And this 1.5. 1.5. Yeah. This is the MTC 819 is 1.5 HP. It is a hermetic compressor. Here we have the pressure switch, the high pressure switch, and this is the low temperature. And that one is adjustable, and this one is already set from fabric. And here is the microchannel. As you can see, the microchannel is this side. If you compare versus, you know, look, size, it is totally different. You know, the space with the smaller footprint, we can put all the components inside. Yeah, as you can see, you compare even that one that is a smaller condensing unit. You know, the footprint, the white, it is bigger because you need a bigger condenser. And the advantage of this one is the protection, because it's totally hermetic. It's a plastic condensing unit for the blue one. So the IP protection, I believe, is 68. And also one of the waterproof. Yeah, waterproof. Yes, sí. And one of the advantages of this specific condensing unit, it is this on switch. So you could do service with that one. You could turn off the compressor, I mean the condensing unit from here. If you are upstairs, you don't need to close the solenoid valve in the controller that is downstairs on the chamber. And if you are on the roof, you only do this and turn off and do the service. You know, so that's one of the advantages of this condensing unit, that you have to add this in order to do more easy for service. And you know, it's super easy to change, you know, all the accessories like this one. You close the valve and you could replace this one. Also the filter dryer and the cyclone, and the compressor, right? For that one, it is pretty similar as this one. The only difference is that for the North American market, in order to have UL,
I don't know why. You need to have, like, the electrical box must be, like this. So that's the reason that we put it like that way. Also, of course, it's bigger. So the advantage of that, or the benefit of this is that you have more room to add the controller. So you could, so contractors or whatever you may need for the evaporator, or you have enough room there to put it. To put this controller or this one, well, this one, if it is standalone. So it's super easy. You don't need to open all the condensing units in order to only remove that cover. Only, yeah, you need to remove that cover, and you're gonna do it. Or if you want to do the change of the KP, you only need to remove this one, and you could adjust the pressure switches, the KP of low pressure switch. And also, it is pretty similar like that one. All the compressors have a service valve in order to replace it. And, filter wire and glass also threaded, so you could replace it easily. And you could close the service valve that is inside of the receiver and do the service. Super easy. Also has the micro channel that is here. With a smaller footprint, we have this is a 1.5 low component. Yeah, so it's pretty similar to that one. Of course, that indoor unit, and that's how.
Pero ¿cuál es la diferencia que hay? Por Danfoss, ¿cuál es la diferencia?
El core.
Both are
¿Verdad?
those
Latin America.
the only difference is the certification. This is certified by UL, and this one is not. Because we need to certify all the components must be certified by UL and also the condensing. So it is a higher price, but you need to pay, the certification of the unit every year, and all the components are more efficient. All the components are certified, also, so we need to pay for that. So that's the reason of the difference of prices. Of course, the outdoor unit is more protected for ambient. Both. If you put a roof on that one, could
We have
also
an
work.
enclosure. We have an enclosure for that one.
Yeah.
Made by that.
Yeah. Also, we have another version that is for Canadian market and also for the north part, that we add a pressure switch, a pressure valve that allows us that if the temperature go below zero Celsius, below 32 Fahrenheit, with two things that we add to that one, we call it the low ambient kit, that is a pressure valve and also a crankcase heater for the receiver and for the compressor. We ensure that if we have a temperature below frozen temperatures, we could operate the condensing unit. So we have also that version if you need it.
Two more things that I want to before we close the session. The evaporators. The difference this one, there are ECM motors.
All the motors are ECMs. It is easier to open the door for the panel of the defrost. Also, it's super easy to open the electronic connectors, and also here we have easy door or open. It is easy to open the door to do the installation of the TXV or the solenoid valve and all that. Is super easy to open it, and it's open 360. So you're gonna move to this position. So you're gonna have enough room to work on both sides.
The last thing that I wanted to show them is the, we have a condensing unit open outside. Let's go outside and let's show you.
No, menos que todavía el,
All the units from
¿De cuánto
De DHP.
De DHP. Ese compresor parece de 3.
maybe.
Sí, pero parece de 3.
This is Danfoss.
¿Verdad?
It's a German compressor because
El eficiencia de los condensadores.
4 years ago, Danfoss bought this box brand. Now it's part of Danfoss, of course. So it's a German compressor. Actually, since I believe 20 years ago, Danfoss distributed this kind of compressor in Latin America. Now we bought it about 5 years ago, and those compressors started from 2.5 HP till 80 HP. We have two types. Well, for this condensing unit, it's hermetic, semi-hermetic compressors.
Pero ese compresor es de la Danfoss.
In Danfoss, no?
Yeah.
Yeah.
Danfoss.
Since
Primera
5
vez que lo
years
veo.
ago. Yeah. 5 years ago. And it's a German. We made it in Germany. And these units started from this one started from 5 HP to 20 HP. Okay. Did it with microchannel. And yeah, it's pretty similar. What we do is also we put service valves in both sides of pipes, consumption and discharge. Also, we have a receiver, so an accumulator, suction accumulator.
There is also separator.
Yeah, and also separator in order to maintain enough oil for the compressor. It's also, electrical box with the thing that I just explained you in the other machine, that if you want to do service, you will turn on or turn off the machine from here, and you don't need to go downstairs to the cold room in order to do the pump down.
And these compressors are made by Danfoss. What he was saying was that when Danfoss bought the factory at Germany, the name of the compressor is BOCK Bock, which is a recognized brand for many years, doing the semi-hermetic compressor. With Danfoss as the compressor and all the components inside. So if you need to replace any of the components inside, we also have it available, and also the oil level adapter is also available for this brand and for Copeland or for any other manufacturer.
Yeah, one of the things that he mentioned, remember that I mentioned during the presentation is that 90% of the component, even the piping, and the frames and all that, we build it in a factory. So if you need replacement, we have it, and in Galpa could have a stock of those. So the compressor, and as Horacio said, all the internal components, the plates, the orifices, and all the internal components, we also have spare parts for those to replace it. Also, we have service factories in order to manufacture the compressor. And all the components, filter dryers, side glasses, everything is Danfoss. So you could
replace it easily, even the microchannel. Yeah. So that's one of the good things. And of course, the hermetic compressor is even higher efficiency if you compare versus propane. Yeah, we have the compressor by standalone available and also the condensing unit. Yeah. No, pero hacer pero está.
El 10 caballos no tiene amortiguador en las tuberías.
Pero está.
¿Verdad?
Tiene los pues depende del tamaño. En las grandes capacidades sí tenemos amortiguadores, pero este está diseñado para resistir esas.
No, claro, ya, veo la curva que está ahí en la alta, pero yo me refiero a eso.
El piping, the piping is designed in order to absorb that vibration. For higher capacity, because we have also condensing units from 20 and 60 or 80 HP. And for those, we have.
Yo imagino que eso trabaje.
Está firme.
No
tiene muelle.
Exacto.
It's really efficient, and of course,
Cuando se monte se verá. Cuando se monte se verá.
Mucho que se parte.
Se parte, sí. Sí.
So thank you very much for your time. I could still talking about the product, but I really appreciate your time, and if you have any question, I'm gonna share my information in order that we could ask me wherever you may have a question you have. All right, thank you.
Gracias, Ernesto.
Gracias a ustedes.
Bueno, gracias, no, de verdad que gracias a usted por el tiempo. For very much for the time. For being here, and as you can see, tenemos de todo lo que necesiten para refrigeración, todo. Cortinas plásticas, brackets.
Estaba lejos de la situación. Porque yo siempre moría en una Refrigeration, pero
los accesorios.
El látigo es duro. El látigo es duro, tío.
Los accesorios, las puertas, los heaters.
Está bien, ¿no? Ya yo sé todo eso. Ahora, dame cotizar